So 1.4 deals with sums, difference, products, quotients of different functions. They're written up there, and the idea is if somebody gives you two functions, and they can name them function F and function G, we can ask you to add them, subtract them, multiply them, or divide them. And the idea is you can actually do that first, like do the addition first, and then plug one number into your result, or you could plug the number into the two original functions and then add the answers. And the idea is they turn out to be the same. First thing I'm going to do is switch these functions out. So cross them off. We'll make f of x 2x plus 3. And how about we make g of x x minus 4. So the first time they ask us to add them together, I'm going to write 2x plus 3 plus x minus 4. So I'm just adding the two functions together. Then all we're doing is looking for like terms. So the 2x and the x go together. The 3 and the negative 4 go together. And I end up with 3x minus 1. What's the domain for 3x minus 1? It's a linear, non-vertical, right? So negative infinity to infinity. So when you're asked to do this, we would never leave it up here where we have a bunch of like terms that could be combined because you're not simplifying. So always simplify them as far as you can. When you do the subtraction, I suggest you use a set of parentheses. So minus, so that maybe on the first step, all you're going to do is distribute the negative sign. So negative x plus 4. Now when I combine like terms, I have 2x minus x, 3 plus 4. What's the domain of that function? X plus 7 is also linear, non-vertical, so negative infinity. Multiplying. You will end up doing a FOIL method or a box method, but 2x times x gives me 2x squared. Depending on how you do this, you might go 2x times negative 4 gives me negative 8x. 3 times x gives me 3x. And 3 times negative 4 gives me negative 12. Now some of you might do your first and last and be able to do the OI mentally, but we end up with 2x squared minus 5x minus 12. That's a quadratic or a parabola. What's the domain of a parabola? U-shaped graph. Right? It's going to continue to get wider forever. And then finally, the last one is division. So it's 2x plus 3 divided by x minus 4. There's nothing we can do there.
Did you cross out the x?
No. A lot of people do want to cross off the x, but the idea is it's 2x plus 3 is being divided by x minus 4. If you take the x's away, you're changing. Yeah, so no. You can write 2x over x minus 4 and 3 over x minus 4, like you can split them apart, but what's the domain? Well, when you look at the rational expression, we have a linear on top, which is all reals. We have a linear on the bottom, which is all reals. So you kind of start to think, well, anything works, right? But because it's a rational expression, what are we concerned about? So you would take your denominator, set it equal to 0. And what happens if x is 4? And we can't do that, right? So it's undefined at x equals 4. So here you might say all reals such that x is not equal to 4. Other people might go negative infinity up to 4, skip over 4 to infinity, whatever you prefer. Somehow you have to say everything works but 4. Now, if this were a test question, one of the things I would want is some way to check my answers, right? Because let's be honest, the work was pretty easy. The work's pretty easy, but maybe you made, a sign error. You might have accidentally multiplied instead of adding. Something weird might happen. So the idea is we're going to do the same functions, but this is how you would check. What were my two functions again? I wrote down f of x was 2x plus 1.
3.
Oh, jeepers. Okay. 3. And the second one, g of x was x minus 4. Okay. What did we get for an answer when we did f plus g? What was that answer? What? 3x minus 1. Okay, so here's how you check your work. What happens when I put 3 into the green function? I get 3 times 3 minus 1, and I get 8. Let's take the 3 and plug it up into the red function. So if I plug 3 into the red function, I get 2 times 3 plus 3. 2 times 3 is 6 plus 3 is 9. And when I plug 3 into the blue function, I get 3 minus 4, which is negative 1. What happens when I take the red answer and the blue answer and add them together? I get the same as what I did in green. So that isn't something that I would necessarily feel like I have to write down. Like if I was just going back to check my work, you have all the functions sitting in front of you, you probably can plug the 3 into your answer and then plug the 3 back into the originals and kind of do everything mentally and check your work. If they would turn out to be different answers, you made an error. If I plug in 4, so what was the resulting quadratic that we got? So when we did f g of x, it was 3x squared.
2x.
Oh boy. 2x squared minus 5x minus 12. Okay. So when I plug in 4, I get 2 times 4 squared minus 5 times 4 minus 12. So this is 16 times 2, which is 32 minus 32, right? So I'm getting a 0. when you plug it into the red, when you plug in 4 to the red equation, 2 times 4 plus 3 is 11. And when I plug it into, what? Never mind. 4 minus 4, I get 0. What's 11 times 0? So when you take the red 11 times the blue 0, I also get 0. So it does match our purple answer. And that tells me that I probably have the right answer. The one that I would always check, because it's your guys' most common error, is the subtraction. So if somebody's sitting near you, do the subtraction. Just do all 3. Plug 2 into the result, and then into the individual original equation, see what you get. Show the person next to you, make sure you do it. And the reason why is a lot of you forget to put parentheses around that other function when you're subtracting, and you end up with something wrong. Was x plus 7 the original, or our answer, I should say? Yeah. Right. So when you plug in 2, I get 2 plus 7, and I'm getting a 9 for an answer. And then we would just check real quick. When you plug it into the original, 2 times 2 plus 3, I'm getting 7. And in blue, plugging in 2 there, I have 2 minus 4, which is giving me negative 2, right? So you might look at that and say, oh, I don't get it. But what is 7 minus negative 2? Right. So 7 minus negative 2, you're actually adding that 2 now. And so you do get 9 in both cases. Again, it's not that the work is terribly difficult. We make simple errors. And this is a way that you can actually check your work. Just plug a simple number into the 2 original functions, into a resulting function that you're checking, and you should get